Okay, this is part 3 of 7b, looking at combining probabilities. So we're going to look at some last questions here of assorted probabilities. We're going to use this method of our choice that we feel is best for each of these different problems. So the first is we're spinning 2 winners in a row with a wheel of fortune on which the winner is one of 36 equally likely outcomes. So this tells us the probability of a win is 1 in 36. Now if we look at this, this is the probability that we win the first time and we win the second time. So this is an and probability. So hopefully you're thinking multiplication. With and probabilities, we need to look at dependency, and I think these things are definitely independent because the first spin is not going to necessarily affect the second spin in most cases unless you, I don't know, break or distort or bend or something like that the wheel on the first round, but still I think we're pretty safe to assume independence there. So the probability of winning a win is 1 in 36 times 1 in 36, and if we multiply those out we get 1 over 1296. So that's the likelihood of spinning 2 winners in a row in this Wheel of Fortune, where you have a probability of 1 in 36 equally likely outcomes of winning. Okay, the next one, 42, is probability of drawing a 6, 7, or 8 from a standard deck of cards. So again, there's that word or. So when you see or, hopefully your brain thinks add. So the probability of drawing a 6, there are 4 out of 52. Probability of drawing a 7 is the same, and the probability of drawing an 8 is the same. All of these are 4 out of 52 because there are 4 out of the 52 deck of cards. Now there's no overlapping here because 6, 7, and 8, those don't overlap, so this is a non-overlapping event. So the probability of drawing a 6 or a 7 or an 8 is just going to be the sum of those 3 things. 4 out of 52 plus 4 out of 52 plus 4 out of 52, which is going to be 12 out of 52, and 4 goes into both of those, so that will be 3 out of, I cannot write today, 3 out of 13. So there's a 3 in 13 chance of drawing a 6, 7, or an 8 from a random normal deck of cards. Okay, and next one here, what's the probability of meeting at least one left-handed person in 8 random encounters on campus when the incident rate of left-handedness is 11%, meaning 11 in 100 people are left-handed. And I turn out to be one of those 11% myself. So we're looking at least one. So when we see at least one, we're going to be looking at the complement, probability of none. So we want to look at probability that someone is not left-handed. Okay, this is going to be 89% or 0.89, because the probability someone is left-handed is 11%. So then the complement of that has got to be basically 1 minus 11%, which is 89%, because those have to add up to 100%. So the probability that someone is not left-handed is 0.89. So the probability that you meet at least one left-handed person is going to be 1 minus the probability of none, and this is 8 people. So out of 8 people there, we're going to take 1 minus the probability they're not left-handed. I should have said, so this probability not left-handed is what I should have written here. So 1 minus 0.89 raised to the 8th power, and if you plug it into the calculator, you get approximately 0.606. There's about a 60.6% chance that you will meet at least one left-handed person if you go up and meet 8 and have 8 random encounters. So that's a look at Unit 7B. I did mention before that we would look at that original problem of our con man, who originally thought that you would take 4 times 1/6 to get 4/6, and that was the probability of him winning, of rolling at least 1/6 in 4 rolls. And so let's take a look at how this would actually be calculated, because again, he got 0.67. Well, again, he's looking, what's the probability of at least 1/6? Oops, I should just write the number. So the probability of at least 1/6. Well, this would be 1 minus the probability of not getting a 6. And the probability of not getting a 6, well, and this is out of 4 different chances as well. So this would be 1 minus the probability of not getting a 6 is 5/6. So raise it to the 4th power, and this gives you approximately 0.52 on that. So that's where he went wrong in his assumption. He was still going to be winning because 52% of the time he would be right. So over the long haul he would win. But his concept falls apart quite quickly because that's definitely a true statement, but this is definitely not right here. The same thing can be applied if you're wondering on the other event, probability of it getting at least a double 6. That'd be 1 minus the probability of no double 6. And this was out of 24 tries when you look at that second event. So this would be 1 minus the double 6 does not occur. There's 36 different outcomes. So 35 of those 36 are not going to be a double 6. So you get 1 minus 35 over 36, and then you got to raise that to the 24th power because he's doing 24 attempts. And get about 0.49. So over the long haul, this guy is going to lose more than he's going to win. So that's just a look if you were curious as to what those actual numbers are. And that takes us and wraps us up for Unit 7B. If you have any questions, please do not hesitate to let me know. And I appreciate your time so much.